Welcome to part 2 of the video example on finding the Norton's theorem equivalent circuit for a bridge network. In part 1, we found the Norton equivalent circuit by finding the open circuit voltage and the short circuit current, and then finding the Thevenin equivalent resistance, which is also the Norton equivalent resistance, as the ratio of the two. In this video, we'll show how to find the equivalent resistance by just finding the equivalent resistance of this network. We can do that because this network has no dependent sources. And as long as the network has no dependent sources, we can find the equivalent resistance fairly easily. So, what we do is we get rid of the source, the independent source, and we replace it by a short circuit because it's a voltage source. If it were a current source, then we would replace it by an open circuit. And now we want to find the equivalent resistance between these two terminals. Now, this is going to be a little tricky, not because it's inherently difficult, but because things are put together in a way that you're not used to seeing them. So what I'll do is redraw the circuit. So we'll take this terminal and put it here. Okay. We now have two 350 ohm resistors that are connected to this terminal. So in fact, kind of clear up this line. I got a little overexcited there. Okay. Now we have this resistor and this resistor connected to this terminal. So let's draw them connected to the terminal. But you'll notice that I'm going to draw them in such a way that their relationship to each other is a lot clearer. Okay, so this might be the top one here. And this might be the bottom one here. Now you'll notice that the other side of the resistors are both connected to this point in the circuit. So I've connected the other ends of the two resistors. You'll also notice that this 350 ohm resistor and this 400 ohm resistor are both connected to these 2 points as well. So I will draw those in. So here we have 350 ohms. Here we have 400 ohms. And you can see that on the other side of these resistors, they're connected to the other terminal. Okay, so when I draw it this way, hopefully it's much clearer that I have two parallel combinations which are in series with each other. So let's start with the top parallel combination. These two guys. In parallel, two 350 ohm resistors will just be half of 350 ohms, which is 175 ohms. Okay, and let's now look at the 350 in parallel with the 400. Whoops. Make little random marks on the screen as well. And a 350 ohm resistor in parallel with a 400 ohm resistor is 350 times 400 divided by 350 plus 400, which turns out to be 186.67 ohms. And again, I still have the same terminals and the same connections. And now this I can simplify into just a single resistor whose resistance will be 186 plus 175, which turns out to be 361.67, assuming I've done this correctly. So there you have it. That's the Thevenin equivalent resistance. And we found that by finding the equivalent resistance of the circuit between the two terminals with the voltage source set to 0. And with that, we'll complete this video.